bear with us. This is our very first webinar, and we're very excited to have you. So as you may be aware, trueCABLE is focused on low voltage Ethernet copper twisted pair cabling. And there's going to be some upcoming stuff we're going to talk about at the end. So I suggest you stick around because we got a lot of new stuff coming. But first, I am Don Schultz, and I work for trueCABLE as the technical expert. My primary focus at trueCABLE is content, for example, right here, along with testing, quality assurance. I'm also a Fluke Network certified cable test technician and a Bixby copper certified technician as well. So I've got about 10 years in the business of putting an Ethernet cable, and I do my own side installs. So a lot of the content you see on our Cable Academy at our website, some of it you see in a lighted box, some of it you see actually outside. Some of those outside videos are actually my projects that I've got going outside of trueCABLE. All right, so this webinar is about selecting the best cable for the job. And let me tell you, when it comes to selecting the best cable for the job, the selection may not be as straightforward as you might like to think. There are a number of things that you have to take into consideration when you're trying to figure out the right cable. Are you basing your selections on just bandwidth that you need? Or, is it going to be based on the installation location, or maybe it's usability? Some cables a lot thicker and more difficult to work with than other cables. So there's a lot of considerations that go into selecting the right cable. The very first thing we'll talk about, and one of the most important things, especially if you're a commercial installer, is cable jacket types. Now, cable jacket types are super important because it really does define how durable your cable is going to be in the environment you install it in. If you're a commercial installer, a lot of those choices have actually been taken away from you because by code, there are certain cable types you must install. And so you would actually get in trouble from the person that wrote the contract for you, or actually maybe even an inspector, a local code inspector, who would force you to remove the cabling that you put in because it's the wrong cable jacket for the structure, or they could even fine you. So it's very important. Commercial installers pay attention to this. Residential is a lot less restrictive, and we'll talk about the differences. All right, so the jacket types that you primarily see out there we'll talk about the first two separately and then the last two kind of together because they do sort of belong together. These are what we're talking about when we're talking about bulk unterminated Ethernet cable. The two main types you see used in commercial structures is riser rated and plenum rated. So the riser rated is something that does not promote the spread of flame. It's PVC, it's a plastic jacket. Therefore, it can burn. And if it does burn, it'll give off toxic gas, toxic smoke, like any burning plastic or PVC especially will. And so what riser rated is for is going up into walls and between floors and things like that. And there's another slide we'll get to right after this. So it'll kind of show the differences between riser and plenum and where you see them used. But riser is something that is coated typically with a Teflon spray coating. And that's the only special thing about it. Otherwise, if it didn't have that Teflon spray coating, it would just be called CM or CMG. So it's the most common installed commercial style cable jacket you see. It's also the least costly general use indoor cable jacket. Riser rated cable may not be used outside, period, end of story, not inside of a conduit. There's no way around that, and there's reasons why. When it comes to the next one up, that's plenum rated. Now, that's a specialty cable that is designed for fire rating. And that stuff is actually resistant to lighting on fire. And if it even should light on fire, it's supposed to auto extinguish within 5 feet on either side of where that fire begins. And that's actually by ETL and UL. 50% of the weight of the cable jacket is actually Teflon that's baked in as opposed to sprayed on. And it is by far the most costly cable there is to install per foot. It's twice as expensive as riser rated cable on a per foot basis. Plenum rated cable is used in commercial structures where the air handling takes place. Typically, that is going to be in the plenum, that's called the plenum space, and that's going to be above a drop ceiling or below a raised floor. And you have air returns and other types of air movement going on in those spaces inside of office buildings, because using ducts would be prohibitively expensive. So they use those spaces to move air around. The last thing you want is for a cable or for a fire to occur in just one isolated place in your building, and for a cable to off-gas toxic smoke and then very quickly move that toxic smoke to a completely and unaffected side of your structure, effectively choking out the people, 500 feet away, even though they might even know a fire is taking place, yet they're dying because they've got toxic smoke being piped into their room. So that is what plenum rated cable is for. And it's designed to prevent really, really nasty toxic PVC smoke from coming in to get you. The last two we'll talk about on this slide are outdoor style cables. Now, outdoor cabling, both types, whether it's, trueCABLE, we separate our outdoor from direct burial. They both have the same outer jacket. It's called a low linear density polyethylene. Let me repeat that, low linear density polyethylene. And that type of jacket is designed to be resistant to UV radiation, to rain, snow, ice, severe temperature swings, and also to resist cracking if you install it down to the maximum install temperature of -4 degrees Fahrenheit. Although if you're out there installing cabling in -4 degrees Fahrenheit, well, okay. I mean, I would never do that, but hey, it can take it. Anyway, the direct burial cable is something that has a little additional water protection. Now, let's not get this mistaken. The primary protection for any outdoor cable, whether it's direct burial or not, is that really thick, tough LLDPE jacket, which is just brutally tough. It's different to strip through. You'll know you're dealing with it when you come to it, believe me. And it is the primary protection for your cable. But the direct burials have either a waterproof tape, which is a wraparound, and it's a water absorbent tape that ends up kind of expanding inside the cable. And then there's also gel filled. And both of those mechanisms are designed to prevent the ingress of water if your cable jacket should get breached. The flame resistance of direct burial cable and outdoor cable is basically zero. I mean, it's not flammable, okay, but it's not designed to mitigate a fire in any way, shape, or form. So if it does light on fire, it can burn at a very high temperature. Although if your structure's on fire, you probably have bigger things to worry about. But the fact is that outdoor cable may not be used inside of commercial structures, except in one exception, which we'll go to on the next slide. Where can you use this stuff? Well, when it comes to what to use where, we're going to talk about the National Fire Protection Act and the National Electric Code, Article 800. Now, where these things are found at in Article 800, it tends to be scattered. And there's another article in NEC that somewhat addresses this as well, Article 250. But when it comes to commercial stuff, it's pretty clear. It's either going to be riser or plenum. In general open spaces inside of a commercial structure, like inside of a work area, like from a keystone jack to a computer, or inside of a server room, it's okay to use CM or CMG, which is known as general. That's okay to do. But if it's inside walls or between floors, it's got to be riser. I mean, it can be plenum, although it doesn't make any sense to use plenum in spaces that don't absolutely require it by code. So use plenum where plenum is needed, and use riser where riser is needed. The main thing is that if you do use outdoor cable in a commercial setting, that's okay. But in a commercial building, you have this thing called, according to the industry term I called an EF, or entrance facility. Cabling can ingress past the entrance facility. Basically, it could just simply be a hole in the wall as your entrance facility, or it could be something a lot more elaborate. But from that point, it can go up to 50 feet before it must be terminated. No ifs, ands, or buts. So you got 50 feet to play with, and then you got to terminate it and transition to indoor style cable, whether that being riser, plenum, or even the CMG if it's an open area. So pretty strict. If you violate those rules, I cannot stress enough that this stuff is, that commercial buildings especially are serious. And there are cases in the past where installer companies, of course, have been held responsible for damage and death from the improper use of the wrong cable jacket in a commercial building. There's a casino incident that happened back in Las Vegas that kind of really brought this to the fore. And I'd like to really bang on this. The individual employees that knowingly used the wrong cable jacket in the commercial structure that resulted in property damage and serious injury and death were held criminally liable. I want to let that sink in. Criminally liable. So you cannot play games when it comes to commercial structures. Now, residential is a whole different ball of wax. There's quite a bit more leeway there. Per the NEC, if you have a residential single or duplex dwelling, and remember, single or duplex dwelling only, you can use any jacket type you like as long as it's got a CM something. It's communications cable rated. So in other words, you can actually use outdoor cable all throughout your residential structure, and there's no code preventing you from doing that. And so it's okay to do. You don't have a plenum space. And quite frankly, if your home's on fire, the last thing you're worried about is your cabling burning. So you're probably going to get out of there. So outdoor cable can be used freely inside of a commercial structure, with the exception that it must be 1/4 inch thick or less. And that's important because we're designing a particular cable around that particular requirement, so you can run it indoors and outdoors freely in a residential environment. But we'll talk about that at the end. In fact, at the end, we're going to discuss a lot of new products. So I strongly suggest you stick around. And then that'll be right after the Q&A. We're also going to send out the recording and also a cross-fitment chart for all of our products, what plugs to use on what keystone jack to use with what, plus your discount code tomorrow. So that's all coming tomorrow. But at the end, we're going to talk about some new products along with the Q&A. Okay, so we'll go to the next slide. And so one of the things you're going to come across out there is what exactly is the difference between solid copper Ethernet and stranded copper Ethernet. Well, solid copper Ethernet is the stuff that you install in a permanent way. That would be something that would be like installed inside of a wall, or it might be a cable that goes outside to a camera and it's designed to be used and installed and never touched again. In other words, it's not something you frequently plug or unplug. Solid copper has the big advantage that it has much less resistance to power over Ethernet, and it's also much better for transmitting data over distance. So, excuse me, I got a frog in my throat, folks. When you are dealing with long distance transmission up to the maximum length for Ethernet, perhaps you've seen a 328-foot number before, or 90 meters, or things like that. They're referencing solid copper in all those situations because solid copper is going to give you the best signal propagation. Stranded copper has its uses. Stranded copper is not all that great for long distance, and it can certainly pose an issue with PoE over distance as well. But where it has that solid copper does not have is flexibility. And flexibility is key when you're dealing with pre-terminated patch cables, and you need to make a tight bend around something, or it's frequently plugged and unplugged. If you do something like that with solid copper cabling, you'll break your solid copper cabling over time. In fact, I've seen it happen in as little as 10 unplugs, believe it or not. So you take a solid piece of metal, you bend it back and forth enough times, it's going to bust. Just as simple as that. But when it comes to selecting the proper conductor that is in your cable, the biggest thing I want to give you a warning about is copper clad aluminum. Now, copper clad aluminum is often referred to as CCA. And the idea is to give you a perceived good value. This stuff is typically much less expensive than solid copper or stranded, or I should say pure copper Ethernet cable. Again, I have to give a very big warning about CCA, and this applies especially to commercial installers. It is absolutely illegal to install copper clad aluminum in a commercial structure, period, end of story. The reason being that the National Electric Code prevents it. You may not use copper clad aluminum to transmit over low voltage or high voltage inside of a commercial building. It is true that there is no specific code addressing copper clad aluminum being used in residential. However, it is not wise. The reason being the copper clad aluminum, I have fluke tested it on a DSX 8000. I can't get copper clad aluminum to pass category testing. And it's terrible for power over Ethernet. And in a normal scenario, if you want to call it that, for copper clad aluminum, it could cause a problem with getting enough power to your PoE device, that it would actually end up destroying your PoE device because it's not getting enough juice. That is, or bad data transmission, because copper clad aluminum is really not all that great for transmitting data either. I know that there's going to be people out there anecdotally that say, you know what, I've used copper clad aluminum and it worked, and I'm great. Okay, that's great. Go back there 5 years later and tell me if it's still working properly. The reason being that aluminum will rust like any other metal, like steel or copper, into what is known, it oxidizes. Copper oxide is conductive. So as copper ages, it stays conductive. As aluminum ages, aluminum oxide, which is known for using like in tools to sharpen steel, like knife blades, is not conductive at all. So your terminations will eventually fail. So aluminum, copper clad aluminum will eventually fail. Do not use it. It is a potential fire hazard in the extreme edge case scenarios. So just don't use it. The next big question that often I'm asked about, apart from cable jacket type, is should I be using shielded or should I be using unshielded Ethernet cable? Well, by definition, Ethernet cable, even in its so-called unshielded form, is actually mildly shielded, because the copper twisted pairs, it's known as balanced twisted pair Ethernet cable, is already pretty immune to outside interference. So for the vast majority of installations, we're talking 95% or more maybe, unshielded Ethernet cable is what you're going to want to use. And fortunately so, because it's less expensive to buy. The termination hardware is less expensive to buy. It is easier to install because it's typically going to be not as thick. You also don't have to worry about bonding and grounding problems. But if you do need shielded cable, then by all means use it. But the question is, where might you need shielded? Well, shielded cables are suitable in situations where you're running parallel to electrical and you can't maintain at least an 8-inch separation on parallel. Okay, now you can cross at right angles all you like, but on parallel, that is where the real issue comes in with electrical. So if you can't maintain an 8-inch separation, and I recommend you strive to, then you may be forced into going shielded. If you're in a factory environment and you've got a lot of 480 volt electricity that's being piped to machines, you've got big electrical motors going on, lots of DC voltage converters going on, then you may have no choice but to not only use shielded, but to also stick it into grounded metal conduit as well. So the shielded cable has a use. Just be aware that it's more difficult to install. It can't take a bend nearly as easily. It's going to cost more, so don't use it unless you must. So how do you tell, like, for example, on a cable, you're going to notice that there's a naming scheme. Now, this isn't officially official, actually. Even by Bixby standards, who sets um, a lot of the recommendations for the industry, this isn't fully fleshed out. But I'm going to give you the generally used nomenclature here. So you have a XX/YYY. And so you might see something on a cable that says UUTP. Some people just simply refer to it as UTP. Well, UTP isn't quite accurate. What they're talking about is fully unshielded, just normal, regular, unshielded, twisted pair Ethernet cable. So that really is called UUTP. So the two characters before the slash stand for whether the cable is unshielded or whether it has either a foil or braid overall shield going around all the pairs. After the slash, they're talking about whether you have a number or whether your pairs are individually shielded or not, foil shielded. So UUTP is fully unshielded Ethernet. FUTP is an overall foil shield and the individual pairs are not shielded. Those are the two cable types that we carry at trueCABLE. That addresses the vast majority of the market. When you start talking about industrial needs, then you start talking about things like individually foil shielded pairs, like UFTP or a screen braid shield over individually foil twisted pairs, or even another variation, which is screen and foil overall, but the pairs are individually unshielded. Those are getting into the industrial types where you're looking to shield from high frequency interference, which foil is good for. And then you've got the braid shield, which is good for interference that is on the low end of the frequency spectrum. So think industrial, factory. And now I'm going to say something really controversial here. We're going to see how many people scream at me and tell me I'm wrong. If you're a average do-it-yourselfer homeowner looking to install Ethernet cable, category selection is arguably the least important concern for you, believe it or not. Now, that's probably going to light a lot of fires and bring it on. And the reason why I'm going to say this very confidently is because even Cat 5e, as of 2018 and the NCTIA 568 2.d spec can handle 2.5 gigabit up to 328 feet, assuming that, again, you're using solid copper and all that. And it's at the right temperature and all that, but temperature can also affect how long you can take cable. But category selection, if you're a homeowner, is, and this is a DIY install, is not so critical. I mean, I do recommend the middle ground usually, but let's start talking about the individual categories, and I'm going to tell you how I came to this conclusion. So category 5E has been around forever, right? I mean, it's going on 22 years old. Does it have relevance in 2021? And the answer is yeah, it certainly does. And it sells like crazy and people still use it. Some of the things about it never has a spline. I mean, you've got 8 conductors inside of a PVC tube. They're twisted into pairs. They're using 24 AWG solid copper conductors normally. There's nothing in the spec that says it has to be 24 AWG. It just normally is. It's operating at 100 megahertz. That is per the spec. And it can go from your lowly 100 megabit to 2.5 gigabit over the longest distance that any Ethernet cable can go. Where is it good for? Well, honestly, it's really good for IoT devices like Ring doorbells, and it's great for really tight housings like surveillance cameras, Wi-Fi access points where you're trying to get, a cable into this hole to get into an enclosure, and some of the thicker, more impressive cable may not be able to fit into those little tight housings. And I have found myself into that situation quite a bit. So oftentimes I'll pick Cat 5e, not because I'm looking for higher performance, but because usability might become a problem. It also has the lowest cost per foot. And it's also easier to terminate because you're not dealing with a spline. The pairs aren't twisted nearly as tightly as Cat 6 or 6A especially. And it can still support PoE and PoE++, up to 30 watts. That's what my recommendation is. Some makers state 60, but I usually set the recommendation at the full length of Cat 5e runs to 30 watt and 300 volt DC. And again, most consumer devices, let me give you an example. Only recently in the computer motherboard market, and like some of the more impressive, expensive Wi-Fi routers you can buy for residential use, are you starting to see 2.5 gigabit Ethernet ports even being introduced? And guess what? Cat 5e addresses that. But, it's probably a good idea to shoot for the middle. And the next one is category 6. Now, Cat 6 is actually what I, generally speaking, unless you have a installation concern, you're dealing with really tight spaces, or you just don't want to deal with a spline, okay, whatever the reason may be. Cat 6 is a wonderful middle ground. It's not as difficult to work with as some of the thicker stuff, and it's only a little more difficult to work with than the Cat 5e. Yes, it's got a spline normally, but it may not have a spline. There is category 6 hitting the market now that does not have a spline. It was designed in such a way that it doesn't require it anymore, which all of a sudden makes it as easy to work with this Cat 5e, except for the fact that it's got the 23 AWG solid copper conductors, which makes it a little bit thicker. The conductor pairs are usually twisted tighter, and the operating frequency of Cat 6 is 250 megahertz. And the reason why is because it can operate up to 5 gigabit or 5G base T up to the maximum 328 feet. Again, with a lot of stars and caveats on that number. It can even support 10 gigabit up to certain distances, depending on the environmental crosstalk that you're experiencing in your particular installation. In some installations, if you're just looking to do a single or a couple 165-foot runs, you can actually get away with running 10 gigabit over category 6. But if you're really going to be running category or 10 gigabit, that's another category. We'll talk about that. But so the 23 AWG conductor is really the biggest advantage, I suppose, for the higher category cables, because it allows you to carry more PoE. So PoE++, which is 8023 BT, up to 60 watts in our case, and 300 volt DC. So now all of a sudden you can start supporting these more impressively powered, like point to zoom, infrared variable focus lens outdoor cameras. You might need more than 30 watts to control a beast like that. So category 6 is a wonderful middle ground. It definitely handles any residential installation I can think of, even for 10 gigabit, because I mean, most houses, you're not going to run 165 feet of cable inside of it. Just how big is your house, right? So it's a wonderful good middle ground. I recommend most people stick right at Cat 6, but there are situations where you might need Cat 6A. Now, Cat 6A is, I'm gonna again probably come right out and say, you've heard of like Cat 7, Cat 8. All right, well, Cat 7 is the ISO more or less equivalent of Cat 6A. Category 8 is definitely approved by TIA for use. Cat 7 is not in the United States. Cat 8 is designed to address really high bandwidth, like 25 gigabit, 40 gigabit, up to about 98 feet or so inside of a data center. So our customer base does not include data centers, so we don't carry Cat 8. And quite honestly, if you're looking at carrying 25 gigabit or 40 gigabit, you really need to be looking at fiber. So Cat 6A really is sort of the end of the road for copper, quite honestly, unless there's some sort of new way of making something or technique that I don't know about. Cat 6A is sort of the end of the road. It's designed to handle 10 gigabit up to the full 328 feet. Because it operates at 500 megahertz, it has to have alien crosstalk protection built into the cable jacket. Now, if you look at the inside of the cable jacket, you'll see what looks like a sawtooth, like a circular saw blade. Well, that is there it's called those are standoffs, and it's molded into the plastic, so it's plastic standoffs. And it's a ribbing on the inside of the cable. It's designed to keep a certain degree of separation between cables in a bundle so that you don't get one cable talking to another cable. That's called alien crosstalk. And that's not a good thing. The unshielded Cat6a, which we carry, or otherwise known as UUTP, always has a spline. And you're always going to see the ribbing in the UTP stuff because there needs to be a way to prevent alien crosstalk and pair-to-pair crosstalk as well. That's what the spline's for, is pair-to-pair crosstalk. Normally, Cat6a is seen with the 23 AWG solid copper conductor, just like Cat6, but it's going to be twisted yet even more tight. So the stuff can be difficult to terminate. In fact, it's probably the most challenging termination you may do. Apart from maybe some of the really thick outdoor shielded Cat6 direct burial stuff we carry. So this stuff doesn't take a bend nearly as well as the lower category cable because it's thicker. It's more finicky to terminate, but it is the most future-proof metallic cable option for Ethernet short of putting in fiber optic. So this is the stuff. If you want to put in Ethernet cable just one time, and you don't care about the fact that it's a little more difficult to terminate, that it needs to you need to be careful with your bends on it, then go, by all means, if you have the money and the wherewithal, go for it. Attack the Cat6a. It's pretty well going to be the last commonly available category in copper twisted pair. That's my prediction. All right, so maybe you've made your decision as to what cable you need. Maybe you actually came into this webinar wondering precisely what cable it was that you were going to need. So let's say you settled on you're a commercial entity, and you need riser rated Cat6 cable. Great. Okay, so what connectors and tools will fit onto our cable or anybody else's cable for that matter? Well, the thing is that it depends on how you're going to do your terminations. In the world of ANSI TIA and BICSI and all the industry organizations, you're going to do what's known as a rack to jack termination. Basically, that is a patch panel to a keystone jack in your wall, and your cabling is hidden inside the wall, and it's terminated to keystone jacks, and it's been punched down. You're not putting on RJ45 plugs. Professional installers that are putting in a structured cabling system, or SCS, and that's what they call it, out in the field, are not putting on RJ45 plugs most of the time. I mean, there's some specialty situations where they might, but generally it's rack to jack. It's punched down to keystone or keystone to keystone, what's known as a permanent link. And that's just normally how you put in solid copper Ethernet cable. There are RJ45 plugs that you can put onto Ethernet cable, and we sell them. We're realistic. We realize that people are going to put RJ45 plugs on the Ethernet cable. I have to warn you that ANSI TIA and BICSI both recommend against people in the field putting on RJ45 plugs because fitment problems can come in, especially when you are going from manufacturer to manufacturer. You're in the Wild West because one category cable is not necessarily built just like the next manufacturer's category cable. There are differences. There are differences in the insulated conductor thickness. Okay, even if it says 23 AWG, that doesn't matter when it comes to RJ45 plugs. How thick the copper plus the insulation is matters. The cable also thickness, the overall thickness may differ. So that's why RJ45 plugs can get you into a whole lot of trouble. But we do provide the option because people are doing, for example, rack to plug, which is a what's known as a modular plug terminated link. Okay, and they might want to use solid copper to get the best distance. Well, okay, then now you need to put an RJ45 plug on. So we sell two primary types. We sell pass-through and we sell the standard kind. We'll talk about pass-through first. They come in either shielded or unshielded. They're the easiest type of RJ45 to terminate, or at least it appears so, because when you put the conductors into the plug, then you can pull them out the front of the plug, confirm your sequence, put it into a tool, terminate it, it flush cuts all the conductors off and you're all hunky-dory, right? Right? Everything's going to go wonderfully. You're going to plug that thing right in and everything's going to go wonderfully for you. Well, yeah, if you buy the plugs and the cable and everything from the same place, I would agree with you. You're probably going to be hunky-dory. However, if you haven't checked your fitment, you're probably going to have a big problem because pass-through plugs are very sensitive to proper fitment. In fact, even in Ethernet cable, because the plastic has a tolerance on it. So when we manufacture Ethernet cable, there could be a 0.03 plus or minus millimeter variance on the thickness of that insulated conductor. Unless the pass-through plug has been properly selected and tested with the cable to account for not only what the plug should fit, but also the potential variances found on the cable, then you could have a very bad day of putting on plugs. So they're real sensitive to fitment because pass-through plugs have to take into account you, the human being. You have to be able to get those conductors through the front of the plug. And you're not a machine, so it has to be designed for a human. So they're sensitive to fitment. So you really should stay within the same brand. When we put out a unshielded Cat6 cable, for example, any of our plugs that are suitable for unshielded category 6 will work with that cable because I've tested it that way. Now we'll switch over and start talking about standard RJ45s. They may or may not come with a load bar. They're not pass-through. They got a solid nose on them, so the conductors aren't coming to the front. If you're familiar with the older style Cat5e plugs, those are kind of like guess, cut, fit, hope for the best, put it on, figure you across a conductor or something. What you're literally doing is like putting your cable next to your plug, flush cutting the conductors to about a half an inch or whatever you figure will work for you. And then you stick it in there and hope against all hope that those conductors don't cross over. That's the old style standard Cat5e plug, and we've got them. If that's your thing, go for it. We've got them. But we also carry a load bar standard RJ45 suitable for Cat6 and Cat6A unshielded cable. In fact, all of the Cat6 and Cat6A unshielded cable that we carry. And the idea behind that thing is you can put the load bar onto it and slide the load bar down to the cable jacket or as close as you can get it. The closer the better. Flush cut at the very beginning of the load bar and then just stick the whole thing into the plug, and it puts those conductors right into the contacts for you. They're far more forgiving in regards to fitment because the conductors are being held much more closely in that load bar than they are, for example, in a pass-through plug prior to termination. They're also more compatible with a wider range of other manufacturers' tools. But they can be a little more challenging to terminate. Even the load bar style, we've gone out of our way to create an easy to work with standard load bar plug because it's got a colored load bar. I mean, you just don't see that, but I insisted that it be green so you could see one. But it's position sensitive, so that can get you into trouble. So they do require more attention to detail, but our standard RJ45s are a great option if pass-throughs might throw you off. The next thing is keystone jacks. Now, when I've talked about rack to jack, this is part of that equation right here. Keystone jacks are what you find mounted in wall plates normally. Now, one of the latest and greatest things is keystone jack patch panels, where you can actually start taking keystone jacks and you take an unloaded patch panel frame, and it's like 24 across, and you start, you terminate your cables and you start clicking in those keystones into this unloaded patch panel. And then on the other end of the cable, you've got another keystone that's mounted into a wall plate. So this is, technically speaking, the correct way to terminate bulk solid copper Ethernet cable. They're far easier to terminate than RJ45 connectors. They're much more forgiving of conductor variance because conductor variance no longer matters in regards to the insulation thickness. One thing to watch out for with keystone jacks is they are category specific. You know what? About a year ago, I had somebody argue with me over Reddit as to whether or not keystone jacks had a printed circuit board inside. And he was trying to this person was trying to convince me that it was just simply metal prongs to golden contacts at the front, directly connected, nothing in the middle. It's just a direct connection. Well, that popped open or literally broke a keystone jack and said, so what's that? That being the printed circuit board right here. Okay, so printed circuit boards and keystone jacks define their category performance. So they're not interchangeable. So if you're going to be using, I should say not interchangeable downwards. So if you use all Cat6A keystone jacks, you're good for Cat6 and Cat5e. All of our keystones, whether they be the punch down or the toolless style, they actually are the same platform. What differs inside them is the printed circuit board. So if you're going to be putting in category 6A cable, you need to use category 6A keystones. If you're putting in category 5E cable, you should use at least a category 5E keystone, but it's okay to use Cat6 or Cat6A. The other decision you need to make with them is whether you're going to use shielded or unshielded. I do recommend you pick the one that fits your cable, because it fits in regards to shielded or unshielded, because shielded keystones tend to be a lot more expensive than unshielded ones do. And again, we said we have the toolless kind, we have the punch down kind. They perform the same, they just terminate differently. One snaps closed, one you got to punch in. That's about it. Okay, so there's another type of termination that we have, and according to the powers that be, okay, that being ANSI, TIA, Bixby, and other industry groups, if you, the end installer, are going to put an RJ45 plug onto a solid copper Ethernet cable, this is how you're supposed to do it, according to all the rules. It's called a field termination plug, and it terminates like a keystone jack in the back. So in other words, it's not sensitive to conductor insulation variance. Okay, so it is something that is far more forgiving of you, the human being. But it doesn't end up in a female port, it ends up in a male connector, that being for an RJ45. So technically speaking, this is how you're supposed to put an RJ45 quote unquote plug onto the end of a solid copper run, a field termination plug. But the thing is, though, is because of the way it's designed, it's huge. I mean, in comparison to a plug. So you're not going to be able to get that thing into a camera housing. You're not going to get that thing into a Wi-Fi access point housing. It's just not going to fit. If all you're looking to do is plug it into the back of a computer or a server or something like that, okay, great, it's going to work. So reality is reality. Oftentimes, the field termination plugs are useful for relocating cables around. They also are re-terminatable 20 times. So if you put a plug on, you got to, then you need to take it off later. You're going to have to cut it. It's done. You got to throw it away. These things over time may save you money because you can keep re-terminating them. Okay, so other tools that we have that terminate. One of our newest tools is our all-in-one crimp and termination tool. Now, okay, we're just going to get this out of the way right up front. Yes, I decided to take the cutter off. It's come up a few times in Amazon reviews. It's come up a few times in live chats. Yes, it does not cut. Okay, yeah, it doesn't cut. But in order to make room for the external ground crimp cavities, I had to take the cutter off. There wasn't a choice. So you will need a separate cutting tool. We have a cutting tool that's coming for that. We'll talk about that. But what it does do really well, though, is that it's got a really good cable stripper on it. The cable stripper that's near the crimp cavity that you see there is really, really effective. In fact, when I go to strip an Ethernet cable nowadays, I'm reaching for this tool to strip it. And I'm not just saying that because, I work for trueCABLE, that's what we sell. No, I literally mean that's the tool that puts the perfect score on the cable jacket, and then I can pop it, and I'm not making conductors or removing cable shields by mistake. It just so happens that it's like the perfect cable stripper as long as your Ethernet cable is between 6.00 millimeter. Actually, you can go a little less. I've tested it to 8.00 millimeter in overall thickness. So basically, to put that in layman's terms, if it's our Cat5e shielded riser or thicker, then this particular stripper handles it easily. If it's our Cat 5e unshielded plenum or unshielded riser, this stripper won't touch it. It's too big to handle that cable. It's also a pass-through crimper, so it's designed to be used with our pass-through plugs, especially our big shielded Cat 6.6a external ground shielded plug, which is also why you see the external ground crimp cavities on that tool. Our easy keystone jack termination tool, which is the tool in the middle, is useful for commercial installers especially, or people that do lots of punch down keystone jacks and they need to do a lot, I mean gobs of them, because it can take what would be a 3-minute process and turn it into a 10-second process. So it can greatly increase your installation speed, because you take the jack that's been pre-threaded, you jam it into the tool, you close the handle, it seats all the conductors and flush cuts them off. Wow, right? Before you had to use a punch down tool. Now you can use a speed tool. The last tool on the right hand, very far right hand, is a parallel crimping plier. Now, before these things got invented, I used to use channel locks to close the housings of toolless keystone jacks, especially. When you're trying to close that housing, I mean, okay, you know what? They're not 100% toolless. I'm just going to tell you right now. You can call it toolless all you like, but it just doesn't need a punch down tool. Beyond that, yeah, you're going to need some tools. I recommend the parallel crimping pliers that we sell because it puts a very even closure pressure on the housing, and it takes a job that, you know, could end up causing you a lot of hand strain and stress after just 2 or 3 of them, and turn it into a no-brainer. So I do use the parallel crimping pliers a lot, especially whenever I'm using the toolless keystones. Some other tools that we offer, yes, we do offer that traditional 110 punch down tool. It even comes with a, you can't see it in this picture, but there's a hook attachment on there that you can fold out. It's got a spudger and it's got a hook. So if you accidentally mispunch something, you can, you know, hook around those 2 conductors and yank them out of the IDC slots. So we do offer a traditional punch down tool that can be used with our punch down keystone jacks. And it's obviously the perfect tool to use with a punch down keystone jack patch panel. It's a good quality one. It's actually shaped like your hand, unlike the other ones that are out there that are shaped more like a brick. I don't understand why anybody would shape some of the punch down tools out there like they have, but maybe it was a producibility thing. I don't know, but I wouldn't stand for it. So therefore, that's how it got designed. The next thing is we got flush cutters. You need those in your kit, period. If you're going to prep up Ethernet cable, you have to have a good pair of flush cutters. If you've been operating without flush cutters, I got a question for you. How you doing it? Because I can't. The next item at the lower left is a keystone jack handheld termination aid. If you've ever been punching down keystone jacks with a punch down tool like above, and you're sitting there next to a wall where there's about a foot of cable coming out, and you're trying to figure out where to brace your jack at, have you ever used it, like put it on the drywall and then started punching it down against the wall? I'm guilty. I'm guilty. Guess what? One time when I did that, I managed to put the termination tool itself through the drywall because I mispunched. And so the termination tool, the handheld tool, is designed to save your walls and your hands, because not only could you accidentally put it through the, well, let's put it this way. If you're trying to punch down a keystone jack in the palm of your hand with a punch down tool, I would suggest you don't get near any sharp objects ever in your life, because that's a dangerous thing to do. The next tool over to the right-hand side, lower right, is our one of the very first tools we released. It is our cut and strip tool. This used to be my go-to tool for stripping and cutting Ethernet cable. But because the stripper on our all-in-one crimper is so good, I often don't reach for this one so much anymore, but it still has some use. It's great for coax as well. You can strip RG6 and RG11 to the quarter prep, and it's got a Velcro braid comb on there, which helps you comb out your braid cable shield down onto coaxial cable. And it's got a really good cable cutter on it. as long as you're not trying to cut anything with any steel content. That's copper only, but it's still a pretty good tool. All right, so some additional accessories that we've added lately. One thing I cannot live without, and I am quite serious about this, is the copper fabric strips. Up until relatively recently, when terminating shielded cable, you would have to strip off the cable jacket and then be looking for an intact cable shield and drain wire. You have to fold back the cable shield, wrap the drain wire around, and then punch it into a keystone jack or try to jam it somehow into an RJ45 plug. That's the old way. What you can do now is you can still do it that way if you want to. There's nothing wrong with it. It works, obviously, but you're just causing yourself more work. So somebody invented something called copper strips. Now, that's not what this is yet. We'll talk about this in just a second, but copper strips, pure copper. And they have a conductive adhesive, and it's a copper strip, and you can cut a piece off, and then you can remove your cable shield, wrap your drain wire around your jacket, and tack down that drain wire with the copper strip. And it gives you a nice broad bonding surface for whatever shielded accessory you're trying to put it into. The copper strips are okay, but they rip really easy. They also tend to crinkle up, so they add potentially thickness to your cable when you're trying to get it into an RJ45 plug. Well, introducing copper fabric strips. These copper fabric strips do exactly what copper strips do, except they're a lot thinner and they're a lot more difficult to rip. And they add no thickness to your terminations. So now you can remove your cable shield, fold back your drain wire, wrap it around, put the copper fabric strip on, and go. It's that simple. Whenever I'm putting on Cat 5e internal ground shielded plugs, that's what I'm using. Even when I'm terminating keystone jacks these days, that's what I'm using. It's just one less hassle to try to fold that cable shield backwards. Or what if you accidentally removed or ripped off your cable shield in the process of stripping, but you didn't nick a conductor? Remember to check for that. Well, now you got to use a copper fabric strip unless you want to take a chance on just using a drain wire by itself. So I can't live without those things. Hook and lap straps are what you should be using, that being Velcro straps. Zip ties are evil. For the biggest problem with zip ties is they tend to focus a lot of force into a small area. So when you're cinching those things tight, okay, and they only work well if they are cinched tight, right? They're going to compress your cable jackets. And geez, I mean, Cat 6A has standoff ribbing inside of it to specifically keep cable jackets more separate, prevent alien crosstalk. So as you cinch cables together and you get those, really cinched down, you're creating yourself not only possibly damaged cable, but a bunch of cables all cross-talking with each other. So don't use zip ties, use hook and loop straps. If by perchance you should run out of your Velcro hook and loop straps and you gotta use a zip tie, put it on lightly and then cut, but you should still be able to turn that zip tie. But don't cinch it down, whatever you do. Now, strain relief boots. There was a time in my life when I thought strain relief boots were cosmetic. And I even put that into a blog. Well, I'm going to do a complete 180 because I follow the science, guys and ladies. The fact is strain relief boots do, in fact, add to the electrical, because it's adding to the mechanical stability of your termination. It's adding to the electrical stability of your termination. What the strain relief boot's primary job is, and yeah, it's cosmetic, but it's also designed to prevent you from bending the cable too much at the connector. And by bending it too much at the connector, now you're putting a lot of stress on the strain latch inside your plug, your unshielded plug, for example. And that can put a lot of additional stress on the golden contacts. That's enough to cause transmission problems or even a bad connection altogether with an RJ45. And remember, RJ45 plugs put on in the field by you are by definition going to potentially be problematic because you're dealing with solid copper, okay? And because plugs have to be human usable. Like I said, you're not a machine. So you need all the help you can get, and strain relief boots help you get there. That
Don, so our first question came when you were covering the Cat 5e slide from Thomas. Asked everything going to POE 24 GA versus 23 GA.
Okay, so there's actually, that's two different questions. The conductor AWG is the thickness of the copper itself. So as the number goes higher, the thickness actually gets thinner. There is nothing in the spec which says that you have to design a cable with a certain thickness of copper. It has to be from 22 to 24 AWG. That's your solid copper range that you can work with. There are some other outlying measurements that are setting the, for example, Ethernet cable may not exceed 9mm overall thickness and things like that. So the main thing to look for is if you're looking to push above 30 watts PoE, my recommendation is to stick with 23 AWG solid copper. You get the benefit of it being able to handle more electricity, and that's in the terms of PoE and data. So you get more bandwidth benefit, and you get more a benefit to push higher wattages of PoE. So it's kind of a two-part thing you got going on there as far as a question.
Awesome. We have a couple of questions from David. I'll just go through the first one. He asked if there was an affordable cable tester. Same, some jobs request a certified tester with printed output, but those are $2,000 or so. What do you think about the Byte Brothers or Triplet LV Pro 30?
I haven't used it. The answer, is there an inexpensive cable tester that's actually worth your money? No, I'm afraid there's not. You've got, let me give you the overall choices in the market here. And the price disparity is extreme. Okay, so you've got your $12 Blinky tester. That tells you whether you got a good wire map. It literally is telling you all about cross, shorts, or anything else, but it tells you zero about performance of the cable. Okay, so it won't tell you if you've got a nicked conductor. It won't tell you if you got too much untwist of your conductors. So it's about useless. I mean, if you know that you can terminate plugs properly, the wire map tester is no longer useful to you. The next step up would be a quasi certifier, basically a bandwidth qualifier. Those start at about $1,200. The Fluke CIQ 100 is an example of that. But now their brand new Link IQ takes cable testing and network testing and combines it into one device. That's $1,700. Okay. Then if you want to use like the Big Daddy, the DSX 8000 like I have, now you're at $12,000 for a starting price. So I'm afraid that once you get above the ability to do a wire map and maybe a length test of some kind, a TDR, time domain reflectometry is what TDR stands for. You just went from like $12 to maybe a few $100s for something that has the TDR in it, to now you're like in $1,000 and you just keep going up and up and up and up. You know what? I know about that problem, about a useful, affordable tester being an unattainable unicorn. Believe me, I know. And I'm working on it. It's not easy. But I'm just telling you right now, I'm not going to give any promises. I'm working on it.
Awesome. So we have another one. Why is CM/CMG cable hard to find? Is it worth it? Oh, sorry. Is it enough less expensive than riser cable to make it worth my time to seek it out?
Okay, so CMG is plain uncoated PVC, so it cannot be used in a commercial environment that needs riser rated, or certainly not in a plenum. It is totally untreated cable jacket. So it's only suitable to be used like inside of, if it's a commercial business, like inside of a room, not, or maybe an open cable tray out in the middle of a factory. but it has very limited use in commercial application. So that's why you don't see a lot of the CM/CMG. If you're going to see the CM/CMG anywhere, it's usually going to be in patch cables, quite frankly, because those are not usually, you don't see one jammed into a wall, right? So you're going to see one, that's where you're going to see it. In my opinion, the riser rated cable has an additional Teflon coating on there, which does add a little bit of lubricity to the cable, make it a little easier to pull maybe. Plus it's got that extra little bit, just a little bit of fire dampening ability on it, which makes it worthwhile over any CM or CMG cable.
Thank you. We will ask one more question. If anybody attending wants to send the messages in the chat, we can follow up with an email afterwards and answer any questions you may have. What is a good way to test new or old patch cables? And what is a patch cord adapter testing?
Very good questions. Okay, so patch cables are the weakest. Okay, well, let me back up a little bit. In the world of Ethernet cable, your weakest link is the termination. Okay, and in the case of a patch cable, you've got two of those on each end, and the weakest link of all is an RJ45 termination. So at the end of a patch cable, you've got two RJ45 plugs. You got a really weak potential point of failure there, right? So when you are testing patch cables, the fact is, unless you've got a Fluke DSX 8000 that can do a battery of tests to a patch cable, there is no way for you, the consumer or installer, unless you've got a DSX 8000, to tell whether you have a truly good patch cable or not for all situations. Now, it is true that a patch cable that will not pass PCA or patch cord adapter testing, there's various kinds of testing out there in the world of professional testing of Ethernet. There's overall channel testing, and then there's various component level tests. One component of a channel is called a permanent link. So that's a permanent link test, PLA, instead of PCA. In the case of a patch cord, that is something that tests just the patch cord by itself, and it measures the crosstalk at both terminations. It's testing return loss and crosstalk on that patch cable. The vast majority of patch cables will fail that test. They're out there right now, 80%. And that's not an underestimation. It's not an overestimation. That is an industry validated number. And that's a number I have personally come across and can vouch for. There is no way for you, the individual person, to know if you've got a good or bad patch cable based on a PCA test, unless you have a Fluke DSX 8000 with the appropriate category PCA adapters, because PCA adapters come in sets of 2 and they come by category. So if you want to test 3 different categories of patch cables, you need 6 adapters. So it's unattainable for the average person. Proper patch cord testing for any use, whether that be in a overall channel or if it's just the only cable being used, like from your router to your computer. The only way to know for a fact is to take the manufacturer's word for it, that we do in fact test the cables and we 100% them and they all work, and we're going to put out documented test results that is indeed how they're tested and they do work properly. But right now, patch cables are the Wild West, and your chances of getting a bad one are very high. And what I mean by bad is there's various degrees of bad. Bad as in it may not pass PoE, but it might work okay for data. Bad as in it may work just fine from your router to your TV. But if you take that very same patch cable and you put it into the context of a much larger overall channel, where you've got 90 meters of solid copper cable, and then you got 2 patch cables at both ends, those patch cables may now cause your overall channel to fail, even though it might have worked from your router to your TV. So there's various shades of failure. Like, you know how they say that life is a bunch of shades of gray? Well, take Ethernet and quadruple that. There's many different shades of failure when it comes to Ethernet. So you have an 80% chance, and again, that's not a joke, of picking up a bad patch cable that's bad in some way when you go to buy a patch cable right now. That is going to change. I'm personally going to make it happen, and it's going to happen quickly. Thank you, everybody, for attending the webinar. This is the first of many. We're going to get into terminations down the line. We're going to get into best installation practices down the line. We're going to get deep diving into shielded cable down the line. There's a lot of different things. And if you have some ideas, please send them to us.